Now let's see what the point of intersection of two lines is, and we also will discuss the condition of concurrency of three lines. Concurrency means that they actually intersect. We need to ensure that the three lines intersect. So this is the general equation of line 1, and this is the general equation of line 2, right? And we have to make sure that these two lines are not parallel, because if they're parallel, right, if the lines are parallel, they'll never intersect. And the way to ensure that they are not parallel, one way is to actually convert the equations into their slope forms. So y is equal to mx plus c forms, right? And then you need to make sure that the gradient, the m of line 1, let's call it m1, is not equal to the gradient of line 2. Let's call it m2, right? But another way, if the equation is given to you in its general form, then just ensure that a1 b2 minus b1 a2 is not equal to 0. a1 is the coefficient of x in line 1, b1 is the coefficient of y in line 1, b2 is the coefficient of y in line 2, and a2 is the coefficient of x in line 2. Okay, let me just rub this off before it becomes very confusing, right? Okay, now that that's cleared, you know that, let's say this is line 1, and let's say this is line 2. They will intersect at this point, right? This point will have coordinates in x and y terms, right? Let's say that this point here is P, right? P. And the coordinates are x1 and y1. And you can find out the values of this x1 and y1 by using this, right? x1 is equal to b1c2 minus b2c1 over a1b2 minus a2b1, and y1 is equal to a2c1 minus a1c2 over a1b2 minus a2b1, right? So it's just easier for you if you actually note down the coefficients of x, the coefficients of y, and the remaining constants from both lines, and then just place them in these two equations. Or you can actually do this in a much simpler way as well, is that if you actually convert both of these equations of line 1 and line 2 into their y is equal to mx plus c forms, then you can solve them simultaneously and eventually find out the values for x1 and y1, which will be the coordinates of their intersection point. Okay, but for general equations you just use these two. Okay, and just to make it very clear to you how you can use the y is equal to mx plus c form, well, what you can do is, for example, let's say that you have this equation 2x plus 3y plus 4 is equal to 0, and you have another line. Let's say the equation is x plus 4y plus 5 is equal to 0, and then what you can do is you can just take the constant to the right hand side in both cases, right? So these will be your two equations, and now you can just solve them simultaneously, and then you can get the values for their intersection point, right? So now let's see the condition of concurrency for three lines. Concurrency means that they intersect at a point. Okay, so there must be three non-parallel lines, and the way to confirm that, let's say that these are the three general equations of the three lines, and the way to confirm if they're concurrent is that the determinant of the coefficients of the lines must be equal to 0. So you'll draw a 3 by 3 matrix with the A values in one column, the B values in the second, and the C values in the third, right? And just to make it very clear, the A's are the coefficients of x, the B's are the coefficients of the y variables, and the C's are constants, the remaining constants. Okay, so they'll not be coefficients of any variable, they'll just be constants. And the determinant of this 3 by 3 matrix must be equal to 0, and in that case the three lines will be concurrent.